So this is Jeff Hamrick at the Financial Analysis Program at the University of San Francisco. I'm going to remind you how to run the Durbin-Watson test in Stata. The Durbin-Watson test, as you'll recall, is a test for first-order serial correlation. You're allowed to use it when you have a cross-sectional model that does not use as an independent variable a lagged version of the dependent variable. So I'm going to use as my example here the data involving the electric bill, which is on the homework assignment. And I'll do a couple of quick things to get a slightly more interesting model to test. The first thing I'll do is I'm going to take the logarithm of the monthly bill. So I'll take the log bill and I'll call that the logarithm of the amount of the bill in dollars. And that's a quick transformation that often is sensible to make to prices, though I don't think it'll make a big difference in this particular case. And the next thing I need to do in order to set myself up to successfully execute the Durbin-Watson test is to define a time variable. So I do have two time variables right here. Those have been imported as strings actually. For most quick and dirty purposes in Stata, I can just create a new time variable that's indexed by integers. So I'm going to do that really quickly. I'm going to generate a variable called time that's equal to just the row number in the data set. And then I'm going to declare the data set now to be a time series data set by using tsset and pointing that function at time, which was the time variable that I just created. So when I do this, I now have a time series data set, and we can use the Durbin-Watson stat function in Stata now. So here's how we proceed. We create a regression model. Let's say I regress the logarithm of the monthly bill against heating degree days, number of family members, whether or not we have a new electric meter, whether or not we have new heat pumps, and I execute this regression. I can study these results. I've got a lot of significant results here, but I execute now dwstat to get the Durbin-Watson statistic. So this Durbin-Watson statistic is 0.88. It depends on two quantities. One is the total number of observations, which is 118. That's right here. And it also depends on the total number of parameters that had to be estimated for the particular regression model. So the total number of parameters that had to be estimated here is 6. I need to pay attention to that quantity when I read a Durbin-Watson table. I'll, in a separate video, talk about how we read a Durbin-Watson table, but this is how we obtain Durbin-Watson test statistic, not a p-value, unfortunately, in Stata. So the key thing to remember for this is that we use this test for cross-sectional models. It's not the best test out there. There's a better test called the Jung-Box Q test. And we can't have as an independent variable a lagged version of the dependent variable. We don't have that here in this case since the logarithm of bill from yesterday is not one of the predictors of the logarithm of the electric bill for today. So we're safe using the Durbin-Watson test here. Okay, thanks.